Hello everyone, in this video I'm going to review another interactive tutorial, how to design the Spiral of Theodorus. So let's get started. I'll load the tutorial. I've downloaded them to my computer so I can simply upload them over here and we'll get started. So this starts with a reference image. Now I want to explain something that when you go to drawing, there's a few different ways of drawing. You have sometimes you want to have more technical drawing, following grids and measurements, and sometimes you just want to follow a sketch that you can draw on simple 2D paper and so on. In this case, this is the idea what we're going to do. We're going to follow a simple textbook example of Theodorus. It could be your own hand drawing or a copy of a page. And the main goal, what you want to do over here, we want to align the origin, which is the origin from my sketch and the origin from the screen. The problem here is that the image is basically blocking the origin from the screen, so we're going to set the opacity to just 50%, and now we can simply use this move gizmo and snap it. So now you can see they're aligned. And once we have that, we're simply going to start tracing that, but there are some tricks. We're not going to have to trace the entire thing. So all I have to trace is the silhouette, the outline. So you can see we click over here and simply go over here. I'm just going to click next, 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 next. As you can see, we simply go over until the last, and when it comes to the last, we just snapping it over here. Now, if you finalize over here, what you see, what we did is we drew a closed polygon, and I stress closed because that's the only way this is going to work. It must be a closed polygon. You see, the same origin point was the starting point when we started drawing around, and the same origin point is the finish point. And now we left out all of these triangles, but the computer will automatically create them, and this is something very interesting that I want to explain how this works. And now we turn on over here, you can see we see all of these triangles. Now what happened is that in polygon modeling applications, many of the tools such as extrusion, fill polygon, and some other tools work with something that is called Delaunay triangulation or constraint triangulation, which basically means that every vertex that you give it to create a triangles are not necessarily, it's a term used because normally there are triangles, but it could also be quads. So it's either triangles or quads. But it's still called triangulation even if it's quads. That's the way the name stems from triangles. But nevertheless, the idea here is that every vertex you give it must be used. It cannot leave out any single vertex, and it can also not add another vertex. Meaning is, if you have some other tools, more parametric modeling tools, for example, if you're going to take about the loft tool, that's something that it's going to interpolate if it needs. It can add curvatures, it can add additional vertices. And in this case, it works totally different. But when you think about a constraint triangulation, everything works depending on how your structure is. Now, if you think about it, if I give you a set of vertices in the outline and then a single set in the origin, the center, in order to make, if it needs to use all of the vertices, everything must be used up and not adding anything. In order to connect everything to be still manifold, I mean, using them means obviously using them in a way that creates manifold geometry. So in order, if you know about manifold, the way it works is that every vertex must be connected to everything else. I mean, in a way that makes a continuous loop. And if you have something in the center, kind of like a cylinder, anything cylindrical, it must naturally connect to everything else that goes out in order to be manifold. That's just how it works. So naturally, if I have a vertex over here and then surrounded by a lot of vertices, this will naturally have to create something like this. Now, there is ways to turn this into kind of quads, but that means you will have to add additional vertices or use other tool that can automatically interpolate. But naturally, you will always get the results. So this is how we were able to save actually drawing all of these lines, because the triangulation will do it automatically. Okay, so with that said, what we're going to do now here is another interesting thing. We're going to use the polygon selection so we can select the entire thing. And as I've just said with the drawing, we drew a polygon, and the same idea is with faces. So we have here many faces. I think there's 16 faces here, but they're all flat and they all are part of this bigger polygon. So if we go to polygon selection, we select them as a polygon. Now, if I would go now down a mode, polygon selection, think about it as the highest mode. That selects the entire thing. If I walk down one, let's say if I go to face selection, you are not going to see visually a change, but technically it's actually going to select all of the faces. And why does it make a difference? The difference makes if I walk down from polygon directly to edges, it will actually select only the edges that we have drawn, because that's the edges from polygon. If I walk down from polygon to faces, and then to edges, it will actually select all of these inner edges as well, because those are the edges from faces. Because as you go down, you basically move them down selectively. So the polygon go down to faces will select all of the faces. From faces to edges will select edges from faces. In our case, I go down from polygon to vertices, and this doesn't matter because the vertices are the same if you go polygon or faces. So if I go to vertices, it selected everything. So what we have just done, the reason we switched from polygon to vertices is just to save us time, not to select everything. Now, I could have used marquee selection, dragging it, but because this already has thickness, I would have selected the bottom ones as well, and it would have been much more difficult. So the easiest way is simply selecting the polygon and then going down to vertices, which selects everything. But I'm trying to deselect now these. So this is another thing that's important to note, that if you hold down your control key and marquee select, it will act as a deselection. So I'm simply going to hold down my control key and marquee select, so it deselects these two. Now we're going to go to move, and we're going to move it by, instead of having a precise value by the location on the screen where it should move, I'm actually going to give it just a value by how much to move it up, and I'm moving it up by 5. So what we're going to do now here is we're going to marquee deselect rather, holding down control key to deselect one, and click a feature called repeat, which is a very helpful feature for these type of stuff. So it just repeats the same thing, and I'm simply going to repeat the same feature where I deselect one and I click repeat, deselect and click repeat, and I'm just going to click next to skip through the other stuff, which is basically the same idea. As you can see, it's just deselect and repeat. It's a little bit repetitive, but this is actually quite good. Now I actually tested, you can do the same thing using the inflate tool. If you use the inflate tool, it will usually inflate from a center pivot, so it will not be as accurate, but the inflate tool has an option to set the origin. So if I would set the inflate tool origin to the origin from the center vertex, it's actually going to do the same thing. The starting point is the same and the finish point is the same if I can move it up, but it's not 100% accurate following like this. And now that we did this method, the manual method that we did, we know it's 100% accurate, that each one is exactly 5 higher than the other one. The height over here is 5, this is 10, this is 15, this is 20, and so on and so forth until the end. So that's basically it, what we did over here. And now what we're going to do here is we're going to select faces. What we're going to do here is, for the purpose that I've shown in other videos as well, the purpose of segmenting the mesh into a few logical segments. So first of all, adding colors for the purpose of coloring, just the purpose of colors, but more importantly to give them a different material, so it's kind of like grouping different parts of the mesh. And the tool we are using is, we open this advanced settings, the gear icon, and in that there's an option loop selection. And this again is a selection trick. How do I select the entire loop, the outside that I'm trying to do? And loop selection is something like this. I've shown it before. You click on one and then you click on its neighbor, and it magically selects the entire loop. And this can only work based on quads. So we have a quads. If you're going to try to loop select this, it's not going to work because these are triangles. So this is where we're going to take advantage of the material selection, as you see in a moment. So we take this and we color it. You can anytime change later the color, but the main thing is we give it some color, so that's not going to be the same color as the other sections. So this becomes a different material. Now we go back to polygon selection. And this is another interesting thing is also that if you go up a level, I said before, when you go down, if you go up, it's being lost what was before. So if you have a faces selection, this was selected as faces. Now if I moved up the polygon, it actually deselected the faces, because going up is losing the lower level, while going down is always keeping it and converting them into the lower level. So I did not need it to deselect this. I simply had to switch to polygon selection, and the faces were deselected. Now it's going to tell me to select this polygon, which again, this is a polygon, it's flat. And the main thing is giving a color. Now here's purely, this is technically not visible, it's on the floor. The whole purpose of doing this is just to isolate this a different thing. And we're going to see it as why, because I need to select now this section. And this is actually interesting. Technically, if you see, if I hover on it, it looks like it wants to select them. This is because this was originally a polygon before we moved them up. And SelfCAD actually does not always update the structure what is a polygon. So this is still considered a polygon, despite the fact it's no longer flat, it's no longer a polygon. If you're going to use any of the tools that rebuild the geometry, for example, simple resolution or anything else, this will no longer be considered as a polygon. Or if you do more tools, destructive tools, kind of like stitch and scoop, anything else that completely rebuilds it, then definitely this will be redefined and will no longer be a polygon. But simply moving and rotating and scaling these stuff actually does not change the fact how they are, and they're still indexed as a polygon. And this is usually expected. This allows you to still work with logical sections. So you have the option to manually rebuild them, simply use any of the tools, but other than that, it's maintained. So technically, I could have simply selected them as a polygon, but it's for a good practice. This tutorial is using how it should be done in case this is no longer considered as a polygon. And in this case, you need to go to material selection. And now because this has a different color, so I can select this as a single material, because regardless how they are, they don't have to be a single section actually. If you would have the same material on the bottom, it would select it as well, which is the reason why we gave a different color for the bottom. And now once we have that, we're going to go to inset. And inset here, if you see over here what's happening here, let me try to move this. You can see what's insetting. It's moving the entire polygon is being actually inset, so it kind of offsets this and gives it some thickness. But that's not what I want. I want this actually to treat as faces, and each face inset, which is what you have individual. Now individual is available now. I've selected that as a material, and actually I have to double check, but I think it behaves now as faces. If you would select this as a polygon, as I said before, you could have technically selected it as a polygon because it was still considered as a polygon. I think the individual will not work, because individual in this case will mean individual polygons. In case you select multiple polygons, for example, the top plus the side, then individual will work, but not work as faces. So in order for us to make this work as faces the way we do it now, we need to have the input as faces. And as I said many times in different videos, that SelfCAD tools are smart tools, and they double down, they know what you have selected. This is why they can have so few features technically that is doing so much, because each feature doubles down. We don't have different modes of polygon, different modes for profile, different modes, anything else. It's a smart tool, knows what you have. So if you would have selected this as a polygon and you want to do what I just did, you probably would have needed to select them as a polygon and then switch down to faces, so it's converted as a face selection, and then you would have the option individual. But I used material selection and the same thing worked. So now that we have this selected, all it's left to do is to make sure this stays. Now it's yellow color now because that's the selection color, but it's technically still the blue, the default color. So we're going to give it a different color. And as I said, you can later change the colors. For now, the main thing is just selecting colors. And now we're going to material selection again. And as you can see now, if I went to material selection, actually somehow it lost the color. I have to actually see how the material is relatively new. I don't know how they switch where it's being lost. But as you can see, I didn't need to deselect, automatically deselected. So what I'm doing now here is I'm going to select this material. And now this is a single material. Because this is basically the only thing has this color, so it automatically selects all of these nice things. And now we can go to the color picker again and give this a color. So this basically, the design here is over. The main thing, the design here is over. And now I have to deselect actually. So I'm clicking on the grid simply to deselect everything. And you have the basic design. Now what we're going to do here is we're going to add text. And I'm going to show here the idea how you can add text to something that is basically not straight. If you see this section over here is actually not aligned with the grid. This is at an angle. So how do I add text to something that is at an angle? And for this, we're going to use the freehand drawing. I've done it in a previous tutorial where I've used it, but then I used an offset over here. Now we're going to do it a little bit different, just to show a different tool how you can solve different problems. So the idea what we're going to do over here is first the same idea I did before. We're going to use a draw plane. I'm going to draw a custom plane. So I'm drawing it here. Now you see this here, actually it's the center point, the origin of here. It doesn't really matter where this is. The main thing is if you draw two lines on any polygon, you give it a plane. If you look at this plane now, if you zoom out, you can see this plane has been created at a certain angle which matches this. Now the idea here is we're going to draw text, and the text needs to be precisely positioned. So this gives it the angle where it should be positioned, but it's still not positioned as far as how deep it should go inside and where exactly should be positioned over here. We're just going to eyeball it a little bit, and then we're going to use the move tool to fix it, just to show how you can actually do this in the move tool as well. So for now, what we're going to do here is we're going to draw text, and we need to type in over here. I'm just going to click next, so it types in Spiral of Theodorus, and we're simply snapping here and here, so it's not precisely positioned. The main idea here is to give the text a certain alignment, and I'm also not adjusting the thickness of it. The default thickness of the text from freehand drawing, when you finalize it, will be 20, so it will be actually going in by a lot, and that's not a problem. If you look at my previous tutorial, I had to make it shorter because it was a thin object. The tetrahedron would have come out, but over here we have enough room, so we can leave it the default, no need to change. and I finalize it. So now you can see actually here, you can see it a little bit coming out on the edge, and this goes in, and it's basically just flat aligned with this. You can only notice it because of the color, but other than that, this is completely flat. And we're going to use stitch and scoop. For stitch and scoop, we need to have at least something touching out, not just completely aligned with it. And also this is just too much to the edge. It comes out from here and it's too much. We just eyeballed it. So here we're going to use the move tool. The problem here is that moving it is by default aligns it with the coordinate system from the, it's called global coordinate system, because with this kind of 3D world that we are in. And in this case, if I move it, I will distort the shape. Not really, I mean, in some cases it may distort the shape, but if I move the entire thing, it's just gonna misplace it, it's gonna lose the angle where it is. So I need to make sure that I can align the coordinates from my move gizmos together with the coordinates that is this plane. So the same idea, we drew the custom plane on the drawing. So we can do the same thing over here, but it's just simpler. So we go down to the manual transformation direction, and we clicking over here, and then clicking over here a single line. Instead of drawing two lines, here it's a single line, gives it a direction. And as you can see now, the gizmos are aligned. So if I move it, I move in this direction, and now I'm simply moving it by 5. So I'm moving it X by 5. So I'm kind of moving it out in this case, because you can see this is now the X. This is actually in our global coordinate system. You can see this is the Z coordinates. But over here, this is a local coordinate system that we have just made, a custom coordinate system. This X is pointing towards back and front. So I just need to move it out. I'll move it out by 5 and simply 5. Now we do the same thing, the Y. Y is normally up and down, the default. But here, the Y is pointing in this direction, which is basically the same direction, the angle as this text is. And I'm going to move it the same thing by 5. And as you can see, it's aligned the way we want it, and I'm closing it. Now what we're going to do here is I'm going to, let's see, I'm going to select here. Okay, deselect this and selecting this. Okay, so now I need to select this shape over here, basically, both shapes, and I'm simply going to use stitch and scoop out this part. We're going to use the difference option. And that's it, basically. We're going to finalize this and switching it to the normal view. And this is basically done. This is how you create Spiral of Theodorus. Okay, hope this was helpful. And please let me know in the comments if you have any questions or suggestions. Until next time, bye. Thanks for watching. Bye.